Okay guys, this is lesson 97, last lesson for the week, and I promise I will get better at doing these, and you'll probably get better also at navigating through all this as the weeks go on. Okay, this lesson is on similar triangles and a concept called indirect measure. First thing with similar triangles, okay, we often use tick marks to show that two measures are equal, okay? So angle A has one tick mark here, angle Z has one tick mark, so the measures of these angles are the same. Angle B has 2 and angle Y has 2, so the measure of those angles are the same, okay? Now, in the book it says, recall from lesson 18 that corresponding angles of similar figures have the same measure. So if these are similar triangles, then the measures of these angles has to be the same, okay? So angle A corresponds to angle Z. This is on page 665. Angle B corresponds to angle Y, and angle C corresponds to angle X. Then there are also sides that correspond to one another. Side AB corresponds to side ZY. Side AC, right here, corresponds to side ZX. And side BC corresponds to side YX. The cool thing that we can do with triangles like this is use a really important math relationship. And it's in the box on page 665. It says the lengths of corresponding sides of similar triangles are proportional. Okay? So that means if I know the length, I'll just make up some numbers. So if I know this is 6 and this is 10, and let's say this is 7, okay? All I have to know is one measure over here, okay, to figure out the other measures. So if this is 6 and this is 12, then this side right here I can figure out, because 6 is to 12, because it's proportional. 6 is to 12 as 10 is to X. 6 is to 12 as 10 is to X. So I can solve this a couple different ways. The easiest way, I think, is to go 120 equals 6x, divide by 6, divide by 6, okay? So what would 120 divided by 6 be? Okay, so that would be 20. Okay, so if you have sides like this, 6 times 2 is 12, 10 times 2 is 20, okay? So you can figure it out a couple of different ways, but that relationship is really important. And as long as you know your triangles are similar, you can use ratios to figure out sides all day long, okay? There's another example of this in the book, okay? So we have these two triangles, okay? And the sides, we have this angle corresponds to this angle, and this one corresponds to this one. You have to always make sure you have lined up your angles that correspond to one another. And so then if this is 6, this is 10, and this is 8, this is 5, this is 3, and this is 4. Now, so the lengths of the corresponding sides of triangles A, this is A, and this is B, okay, are 6 and 3, 8 and 4, and 10 and 5. These pairs of lengths can be written in equal ratios, okay? So that's in your book. I don't need to rewrite it on the board, but it says triangle A is related to triangle B, where 6 is to 3, as 10 is to 5, as 8 is to 4. Okay? Now, if you didn't know any of these numbers, like if this was an X and this was a Y, you could use these relationships and ratios to figure out what the measures of those angles would be. And that's what you're going to do in a lot of your homework problems. Okay? The next concept that's discussed in this chapter, or in this lesson, is the concept of indirect measure. Okay? And what this is talking about is a situation where you have something, and I'll just read the thing in the book. It's talking about a girl named Beth, I believe, or no, Sarah. Sarah looked up and said, "I wonder how tall that tree is." Well, Beth looked down and said, okay, it's Sarah and Beth. Beth looked down and said, "I bet the tree's about 25 feet tall." Beth did not directly measure the tree. Instead, she used her knowledge of proportions to indirectly estimate the height of the tree. So what she was looking at is the length of her shadow and the length of the shadow of the tree. And if you look carefully, the shadows create two similar triangles. Okay, so if this is one triangle, okay, and we have a right angle right there, I have a marker, and this triangle right here also has a right angle, so they're separated down here so you can see them a little bit better, but they're similar triangles. So there's a couple of different ratios that you can use. So let's say Beth, the height of Beth, okay, is proportional to the height of the tree. So that's the height, and that's the height. The length of the shadow of Beth, okay, there's her shadow of Beth, is also proportional to the length of the shadow of the tree. So you can use these ratios to figure out and estimate the height of the tree. So Beth might have known, okay, let's see what the numbers were. She might have known, hopefully she does know how tall she is, okay? So how did she could have said, I know I'm 5 feet tall, okay? And she may have estimated, looking on the ground, that the length of her shadow was 6 feet, okay? And the length of the shadow of the tree, she might have estimated that to be about 30 feet. So then 5 is to x as 6 is to 30. 6x is, and then 150 divided by 6 divided by 6. So the way she could have done that is to say x then would have to equal 25. Okay, so I think you can see the power of using ratios and similar triangles. I'm going to ask you guys to read through the rest of the book, okay? I want you to look through the practice problems. I don't think these are ultra critical for you to work out because you do have problems like this in your lesson or in your homework. But I will tell you the answer to, let's see, B is just an estimate, so you don't have to worry about that. The answer to C is 8. The answer to E is 18, okay? And the answer to F is 12 feet. And the answer to G is 11 feet. Okay, if you're writing these down, try and write it down one more time. I'll tell you one more time. The answer to practice C is 8. Practice E is 18. Practice F is 12. Practice G is about 11. Okay? So work through those in your homework. There will be a test in your packet for next week. And that will be it for this week's work. See you next week.